Let's start. Good afternoon, good evening, and good morning to everyone based on the geography you're connecting from. I'm Shashank, and I hope you all are buckled up for the fascinating ride into the world of applications developed using technology of this decade that's artificial intelligence, or I should say the buzzword AI. AI is the biggest technological revolution of our era. I hope everyone can agree on that. So I'll be hosting your session and I'll be taking you through the journey of how we are revolutionizing material selection using artificial intelligence and how we have developed a tool to answer all your material and mechanical engineering related queries. Sorry. So without further ado, let's dive into the agenda of the session. Now this session is based on three sections, which is the most basic questions which we as a curious child always ask to our elders. That is why, what, and how. In the why section, we'll discuss why we need to integrate mechanical engineering with the artificial intelligence and the challenges we face during the material selection phase of a product design and development cycle. In the what section, we shall discuss what is LLM, that is large language model, and what are the applications of LLM and how these applications have been utilized to develop customized tool for the respective needs or very niche needs as well. Then subsequently we will talk about how we have created an AI expert for material selection, that is the tool MatBot. Now in this slide I would like to discuss why in today's era we need to integrate mechanical engineering with AI, or why mechanical engineering needs artificial intelligence. Let's ask ourselves a question. In the context of modern product development, where engineers face a rapidly expanding library of materials, tighter timelines, and increasing complexity in performance requirements, how can an AI help mechanical engineers to make better design decisions? Right? Mechanical engineering is evolving rapidly due to the increasing complexity of product requirements, shorter development cycles, and the explosion of available materials and technologies. Traditional methods of decision making based on these are mostly based on the experience, handbooks, or scattered data, which is no longer sufficient because this data can be available in different channels, different sources, and you may not be able to touch base on every source in order to get this information, right? Now let's discuss the different points which I have mentioned in this slide, which are the points which mainly highlight why we are integrating or why there is a need to integrate artificial intelligence with mechanical engineering. The first one is the handling complexity. Now, as I already mentioned, thousands of materials are available. Now, AI helps us engineers to cut through complexity by comparing properties and trade-offs automatically, something which is very difficult to do manually, right? Material selection process or the product design and development process itself is a complex process, right? So AI can handle that complexity in a better way as compared to an individual. Now AI models can also identify patterns and relationships in data that humans might overlook, right, leading to smarter and more optimized decisions. In the today's world, when we sit back to do in the very initial stage, when we are sitting back to do the product design and we are collecting the needs, we all understand there can be huge amount of data which we need to scrape through in order to get what is required, right? So manually doing it is very difficult, so that's where AI comes into for help. AI can also analyze large volumes of material and design data in seconds, offering engineers quick recommendations tailored to specific constraints, right? AI systems also reduce the dependency on individual experience or tribal knowledge, ensuring consistency across different teams and projects. Different people may work differently in a particular for a particular goal. The goal is always common. The entire team can work towards that goal, or there is an individual who works towards that goal. Now, the process which everybody follows can be different or it can be a consistent one, but AI helps you to keep that process and the outcome standardized and also consistent at every time, reducing the effect of a particular individual in the entire process, right? AI also helps by automating repetitive evaluations and narrowing down choices quickly. AI reduces development time and accelerates innovation, right? This in turn helps you to reduce time to market. Time to market is the day product development cycle starts and the day it ends. Ends with the product releasing into the market. That is called time to market. Now, in this slide, I would like to talk about challenges specifically with respect to making right material choice. Right? Challenges in selecting the right material. Now, when it comes to material selection, both engineers and non-experts face key challenges. There are certain challenges which I have listed on the slide, but they are not complete. There can be many more, but I have just highlighted few which are important. First one is the overwhelming material choices. Now, with thousands of metals, polymers, composites, and ceramics available, narrowing down to the right material is extremely difficult without proper filtering tools, right? The abundance of choices often leads to the analysis paralysis or reliance on familiar but suboptimal materials, because there is a huge amount of data which is available. Going through the every path and finding out the right material may not be possible for a person who does not come from a mechanical engineering background, or who even a mechanical engineer who does not have a large amount of experience behind him, right? Now the next challenge is the lack of centralized and accessible data. Material properties are scattered across data sheets, textbooks, supplier catalogs, and online sources. Engineers often struggle with inconsistent formats, while non experts may not even know where to begin looking for credible information. Right? Now, it is also very difficult for in translating the design requirements into material properties. We all know whenever there is a design requirement which is provided to us, the requirement is translated into mechanical engineering aspects. Again, based on that, you take decisions and then you make changes in the product. Now, this can be in the new product development or during the sustaining activity as well. You need to translate the design requirements into material properties. Now, such design inputs like lightweight but strong, or it somebody can say heat resistant, or we can also somebody can also ask it needs to be more biocompatible, must be mapped. These requirements must be mapped to the specific material properties. Now, these material properties, for example, can be density, yield strength, or thermal conductivity, etc. This conversion requires technical expertise that common users typically lack, right? Because you need to have a specific subject knowledge in order to do these translations. Now, the next challenge is the complex trade off analysis. Engineers often struggle between the trade offs among cost, performance, durability, manufacturability, and sustainability. Right? Now, this can be like if you are working on a particular parameter in order to like satisfy that particular parameter, but at the same time you should have a most optimized line among all the parameters which are available, right? That's where we want to work in order to do the complete product design and development process. So there are complex trade-offs which are associated with this process. Now, in order to evaluate these parameters simultaneously is a complex even for a professional and nearly impossible for the average consumer. The next challenge is the lack of technical understanding among non-experts, right? So, the general public often select materials based on the brand reputation or appearance rather than the performance metrics. Misunderstanding technical terms like modulus, elongation, or corrosion resistance can lead to poor material choices in DIY, prototyping, or product sourcing as well. Even in the final process, it can lack of knowledge may lead to wrong material selection, or you will not have a complete picture of the materials which are available, particularly for your application. Okay, let's move on to the next slide. Now, there is a poll which I want to do. in which I want you to rate yourself on your AI literacy level, whether you are a pro, you are an intermediate, or you are a beginner in this technology. You have already used this technology, or you are still learning about it. Okay, so I'll start the poll. You will get 30 seconds to answer the question, and your time starts now. Great. 10 seconds more. Please help us with your answers. Okay, time's up. So I see a lot of intermediate and beginners which have joined the webinar. So thank you first of all, and I hope you will get a good learning about this technology and how it has been used to do a to create a material assistant. Let's move on to the next slide, where I want to talk about the what of this session. Now, as if now we already discussed why. The first question which we asked was why a mechanical engineering needs artificial intelligence. The second question which we asked was why we need artificial intelligence, particularly in the material selection process. Right? In this section, we'll discuss what. Okay. So the first question is what is large language model? How this technology has been utilized to create the customized tool that is Matpot. We'll be discussing this in the subsequent slides. But the technology which is associated in order to create or the foundation of the Matbot is LLM. Right? Now, what is LLM? It's an abbreviation for large language models. Now, these are a type of artificial intelligence model, specifically a neural network that is trained on a massive data set of text and code. These models are designed to understand, generate, and manipulate human language. Their largeness refers to the sheer scale of their parameters, often numbering in billions. This scale, combined with advanced training techniques, enables LLMs to perform a wide range of natural language processing or NLP tasks with remarkable proficiencies. Right? Now, I already gave you the definition of what is LLM, but just providing you the definition may not be sufficient for you to understand what exactly it comes with or how exactly it can be utilized to develop a customized tool for yourself as well. So, a LLM you can consider it as a rock clay which yet need to be transformed into a beautiful pot, right? So I told you the definition of the clay, but then let's go on and understand how this clay can be transformed into a pot, which can again be utilized by you for different purposes. Now, this transformation process is the LLM training process, right? How we train it. So there are four steps which are associated in the training, that is data collection, pre-training, fine tuning, and RLHF. Okay, now let's go on and discuss these things one by one, or these phases one by one. The first phase is data collection. Now, gathering a massive data set of text and code from various sorry sources such as books, articles, websites, code repositories, etc. Now, this data is used to train the model. So again, I have to do a particular task, and for that, I need a large amount of data which can be utilized, which can be summarized, which can be all the permutation and combinations can be made in order to get the information which I want from that data. Now, this data can be huge, right? And this huge data can be kept or can be utilized or fetched to LLM so that I can get based the output which I want from that particular data, right? Okay, so that's the data collection process for you. Next one is the pre-training process. Training the model on the collected data using a self-supervised learning objective. This means that the model learns to predict masked words in a sentence or to predict the next word in a sequence, right? And then coming to the fine tuning. Now, in the fine tuning, it is one of the most critical aspects of training, right? Where the model adapts the pre-trained, sorry, In the training, adapting the pre-trained model to specific tasks by training it on a smaller or labeled data set, right? And in the last point, we have RLHF. RLHF stands for reinforced learning from human feedback, right? Now, in this technique is used to align the model's behavior with human preferences. Human evaluators provide feedback on the model's output, and this feedback is used to train a reward model, right? The LLM is then trained to maximize this reward using reinforcement learning. Okay, so consider a matbot. I want a particular answer for a consider stainless steel. I put up a question and then it gives me an answer. Okay, I say what is the composition of stainless steel and it provides me the composition of stainless steel. But then I don't want the answer in this format. I want it to provide what is stainless steel and then provide the composition and then provide are you looking for a specifically for a certain answer or the feedback on particular element, right? So then I go back to matbot and during the training time and I tell him that okay, then I don't want it to be a one word answer, I want it to be a elaborate answer. So that's where the human feedback comes in. Now based on the feedback, the matbot changes itself, changes the format, and then again provide me the answer in the format which I want. And then it tries to, then I give him a reward, and that reward is maximized. So that is the RLHF process. Now, in this slide, we'll discuss about how LLM is revolutionizing the way we seek advice using AI. Hundreds of applications have been developed using LLM. I have included few prominent applications of LLM on this slide. The first one is the natural language generation, generating human quality text for various purposes, such as writing articles, creating marketing copies, and generating code. It can be utilized to create chatbots and conversational AI. So Matbot is an example of a chatbot or conversational AI where you ask a question, based on the answer you again ask a question, and that's where the conversation goes on till you are satisfied with the final answer. Now chatbots in the LM powers the chatbots and virtual assistants that can engage in natural and informative conversations. Next one is the machine learning, where translating text between different languages with high accuracy. That's what we do in machine translation. And text summarization, where condensing long documents into shorter, more concise summaries we create out of the long documents which are available, large amount of documents which are available. It can be a book, it can be an article, it can be research papers where you want to condense them and you want to understand them as a summary. Okay. Now, these LLMs can be question answering format, also answering the questions based on a given context or knowledge base which is available with the LLM. They can be used in code generation also, where you go ahead and generate code from natural language descriptions. It can be used for content creation, that is, assisting with the creation of various types of content, such as blog posts, social media updates, and scripts. I hope by now most of you who have joined the webinar must have used AI in this context at least, where you want to create a particular type of social media post, or you go there and you ask whether the post, whatever data which I'm posting on my social media, is it correct or not? Can you correct it for me? Or you can change it into a particular format so that it is more eye catchy, or so on and so forth, right? Also, an LLM can be used in improving search engine results by understanding the meaning and context of search queries. So, for a long time, Google had been the search engine which most of us have been using. But now, when you go on in the Google and you post a query, the initial portion or the initial part of the answer is an integration of information from various sources summarized into one, and then the sources are listed. So they have been using artificial intelligence in order to concise the summary of the data which is available from various sources. And then you can, if you want to go ahead and find out details about a particular source, you can go ahead and go to the source and read about those information in a detailed manner. Now, we are done with the why section. We are done with the what section, where we discussed what is the technology which can be used. Now let's go on and discuss how we have developed MatBot, right? Be using the what and why section as the base or the foundation of our discussion. Now, we as mechanical engineers, we understand that material selection is one of the most cumbersome tasks in a product design and development process due to the availability of different materials for each application. Now, each material selection is driven by multiple factors, which we already discussed, that is cost, strength, manufacturing, procurement, availability, etc. There can be multiple. Now, let's understand with an example. As per ISO, there are over 100 grades of stainless steel which are available only in stainless steel, right? And every grade is categorized into these grades are categorized into different families, and each family will have its unique properties and application, right? Okay. Now, so based on this problem, we were given a task that we need to develop a material expert that simplifies and optimizes material selection by providing intelligent recommendations based on a verified and reliable database, right? First of all, it has to be an expert who can answer the questions in a simplified and optimized way, which aids material selection for both engineers, non-engineers, laymen, everybody, including everybody, right? But the information which is provided by the tool has to be verified and it should be from reliable database. Okay. And at the same time, once you develop this system enables or enhances the efficiency, accuracy, and cost effectiveness, right? While reducing the dependency on experts. So anybody who comes to MatBot and ask a particular question about material selection will get an answer, irrespective of what is your domain, what is your knowledge base, etc., etc. Correct? Let's move on to the challenges which we have faced while creating this tool. Like, let's take a look at the challenges we faced during the development of this LLM. We started with no prior coding experience. The team consists of mechanical engineers, but now the team has learned a lot about artificial intelligence and machine learning. We started with the question, what is artificial intelligence? That is the very basic question from where we started. And then how we can use this in creating a customized solution for a material selection process. Team focused on three T's in the past few months, that is training, tuning, and testing. Now, this training, tuning, and testing we discussed during the training discussion of the LLM, right? In a previous slide, when we were discussing how an LLM can be trained, right? We did all the data collection from different sources. It can be various research papers, various books, and everything, because we wanted to control the output of the matbot, correct? Because we want it to be accurate and precise and concise at the same time. Now, what was the workflow of the matbot development? We want to talk about the capabilities of the solution we wanted to develop. This slide mentions the benchmark on which we have tested various LLMs available, like ChatGPT by OpenAI, Gemini by Google, Llama by Meta, Grok by XAI, etc. Now, this is not completely exhaustive list of LLMs which we have tested. We have done a few more, but I am just mentioning the prominent ones in this slide. Now, we wanted to integrate LLM with a curated database in order to control the correctness of the response. Okay, so we wanted the database to be completely checked thoroughly by us, what needs to go into that database and what will not go into that database, correct? Because based on the database, it is going to summarize and it is going to provide answers to the particular question. Now, it should be able to provide exact properties corresponding to each material, like density, thermal conductivity, tensile strength, fatigue, impact resistance, etc. It has to be interactive in order to answer follow up queries of the user. The LLM should be able to compare different materials based on multiple criteria, right? If there is a plastic, there is a metal, there is ceramic, there is a composite. If I want to compare these two or three materials, then it should be able to do based on the properties of whatever benchmark you provide, on the basis of which you want to compare these materials. Now, it can be materials, it can be properties, it can be anything else, right? Now, let's move on to the capabilities of MatBot that we have integrated with the tool. The core capabilities of Medbot include custom assistant instructions, that is, define personalized system instructions to control tone, response type, and context specific logic during interactions. Right? The next one is the advanced file search and data reference. That is, leverage the file search tool to query technical documents, standards, data sheets, and proprietary references, ensuring validated material recommendations. Right? The next core capability of MatBot is integrated code interpreter for calculations. MatBot uses built-in calculation capabilities to evaluate material properties, cost performance ratios, environmental factors, or etc. anything. We will be showing this capability to you during the live demo. The next core compatibility, which is part of MatBot, is persistent thread-based context management, which that is maintaining ongoing project-specific discussions with active threads, preserving context and decision history for iterative material selection. So when I'm going to show you the live demo, on the left side you can see whatever conversation you are going through in the tool, you can that thread keeps a history of that conversation, and you can download that thread for your future references, right? On what basis you decided a particular material or any other future reference where you want to come back and understand what were the details which I got from Matbot or data. The next next capability is the dynamic response modulation, which automatically adjusts. That is, MatBot automatically adjusts between detailed technical explanations or single material suggestions based on user instruction within the conversation. Some people may like a long answer. Some people may not like a long answer. They just want it to be short and maybe one word or single line answers. So, based on your prompt, Matbot can decide what type of answer you like, and then it keeps that for all your future conversations. Like that is within the same thread. The last but not the least capability of Matbot is the reference supported decision making. That is, provide qualified traceable answers backed by specific documents or data sources for every material recommendations. Whatever answer you are going to get from the Matbot, you will get a source for that. As if now in this demo version, we have hidden that feature, but then once you get a hands-on in the Matbot, you can go to the exact page and line of the source where it is available for your reference. Okay, we have made this tool that traceable to that extent. Okay, okay. So let's go on to the most exciting part of this webinar, that is the demonstration. So mind you, Uh, I will start the demo session. In the meantime, please feel free to post any material related questions on the chat. And based on the time availability, we will take questions randomly from the chat also. Okay. So as if now, I have prepared a list of questions which I'm asking to Matbot. And the list is, don't worry, it's not an exhaustive list of questions which you can ask to Matbot. But then in the interest of time, I wanted to save time and not type every question one by one. So for because I wanted to show you a wide spectrum of questions which we can ask the Matbot. So I have included in the wide spectrum, I have included simple definition based questions, applications based questions where I have an application, I want to decide the material for that application. I have introduced a conversational thread based question also, where I just interact with Matbot based on the answers which I get. I have included detailed numerical questions also, where I provide different values to it, and based on the formula, it solves the question and provides you an answer to it. Okay. So without further delay, let's move on to the tool. I hope you can see the tool window, and on the left side you see this new chat option is available, and all your conversations will be saved on this side, and you can also search within the conversation. Okay, and I have already logged in, so my login credentials, those you can see over here. You can log out, you can delete your account, you can download summary. As if now it is disabled, as I already mentioned. Okay, and you can also ask expert in order if you want a particular help with respect to a particular topic. Okay, let's move on and put up our first question. So I ask, I'm designing a lightweight drone. What material should I use for its frame and that balances weight and strength? Okay. So first it greets you. Hi, I'm Madbot, your assistant in the material selection journey. For designing a lightweight drone frame that needs to balance weight and strength, carbon fiber is the one of the best materials to consider. Okay, so I'm not going to read the answers every time, but for this first question, I'm just want to make you understand how we have put up the format. So it greets you in the first question, then it provides you an answer to your question. Like here it is saying carbon fiber is the best material. Then after that, it provides you the information why it is providing this particular answer. So in this case, it provides you the detail that it offers exceptional strength to weight ratio, high stiffness, and excellent vibration damping, making it ideal for drone applications where minimizing weight is critical while maintaining structural integrity. So this is the reason that it is providing you carbon fiber. Then after that, it will also provide you alternates available based on different criteria. Okay, so it says alternatively, you can consider aluminum alloy frames, which are lightweight and more cost effective, though slightly less stiff and strong compared to carbon fiber. Okay, so it also provides you an alternative, that is aluminum alloy frames, right? Let's ask one more question. In fact, I'll be asking few more. So the next question I ask is, I need a material for a water tank in hot climate. It should resist UV and not leach chemicals. What do you suggest? So it says that you can use UV resistant polyethylene, or specifically high density polyethylene is an excellent choice. HDPE, again, it provides you the reason why it is selecting that answer. And at the end, it also provides additionally, it's lightweight, durable, and widely used for both residential and commercial purposes. Let's ask something related to. So I ask, is stainless steel better than aluminum for a kitchen knife? So it was an answer when selecting material for kitchen. So this is a comparison based question where I ask whether one particular material is better than other or not. And over here the benchmark which I provided is kitchen knife. That is the application. So while selecting material for kitchen knives, stainless steel is generally preferred over aluminum, and then it provides you the answer. Okay. It also says why you should not use aluminum is because it's lightweight and resistant to corrosion. That is the pro. But the con is it is too soft for knife blades. Let's put up a comparison between copper and aluminum based on the thermal conductivity. So I ask, which material has the highest thermal conductivity, copper or aluminum? It takes few a bit of time because there is a lot of data from where it brings up the answers. So it says copper has significantly higher thermal conductivity than aluminum, and copper's thermal conductivity is about 400 while aluminum is about 235. Okay. Let's ask a normal definition based question where I say, what is the difference between ductility and malleability? Right? We see ductility and malleability are two properties which are found mostly in metals. So then it defines that ductility and malleability are the properties that describe material deformation features, but they refer to different type of deformation. That is, ductility is, as we know, it's for the deformation before rupture, while malleability is ability of to material deform under compressive stress. Now let's ask a random question now. So I just ask a random question where I say, if I were to make a spaceship door handle, which earth-based metal should I use to impress aliens and engineers alike? So it provides you an answer that it says you can use titanium, an outstanding choice. Titanium is strong, lightweight, highly corrosion, and then it provides you the details why it suggests you that particular answer. Uh, just one more random question. What's the most eco-friendly material that I can use to make a coffee mug that looks cool on Instagram? So it is the bamboo fiber composites are eco-friendly and visually appealing. Let's ask a numerical question. This was recently asked in engineering services. I say as this is a thermodynamics based question. A cyclic heat engine operates between a source temperature of 1000 degrees Celsius and a sink temperature of 40 degrees Celsius. What is the least rate rejection heat rejection per kilowatt net output of the engine? So as if now the tabular formats have not been integrated, I'll be talking about the future changes which will come in the MATBOT. But as if now I'm showing you the capability of the tool. The tool is capable of doing the numerical solutions for you, and the answer to the question is 0.327 kilowatt. Okay, let's ask one more question. So I say efficiency of an auto cycle is 60%. The ratio of specific heat is 1.5. What is the compression use? This is a normal automobile question, engineering question. Okay, so then it gives you all the formulas, not in the mathematical format which we want, but in future it will be, and the compression ratio is 6.25. Now let's ask a definition based question where I want to understand the most one of the most fascinating principles which we all learn in the initial days of mechanical engineering. That what there's a difference between torsion, shearing, and bending. So these are the three most common type of failures which materials undergo. That is torsion, shearing, and bending. So it provides you a complete answer. What is torsion? What is shearing? What is bending? Okay, I'm not going through the entire answer. Now let's go on and interact based on the interactive ability of MatBot. So the first question I ask is, what is the most widely used materials in orthopedic implants? It says titanium alloy. It provides you an answer, and it also provides you other popular materials which you can use. Okay. So the next question which I ask is, can same be used as dental implants as well? So it says yes, titanium and its alloys are also the standard materials for dental implants, thereby compatibility allows, so and so is the answer. So then I say, aren't metallic implants susceptible to corrosion? As we know, right? So it says while all metals can corrode under certain conditions, titanium alloys are particularly resistant to corrosion. Then I ask, then why can't I use non-metallic materials? So it says that while non-metallic materials such as ceramics can be used, and it provides you a detailed list of materials which can be used. Okay. Okay. So now I'll go on and let's see if we have any question in the chat. Okay. From the audience, I don't see any question. No issues. Okay. I see a question here. This is asked by one of the person attending the webinar. He says, what is the most suitable material for a self-healing phone screen, and how would its property be engineered to achieve both durability ability to autonomously repair cracks? The most suitable material for self-healing phone screen is polymer-based material embedded with microcapsules containing a healing agent such as liquid polymer and resin, and then it provides you the complete answer. Okay, I'm not reading the answer completely, but I hope you must have got your answer. Okay. Okay, I hope it was intriguing and you're fascinated as well. And again, I'm saying that it's not an exhaustive list of questions which or it's not something that these are the only questions which we can ask. You can ask any question with respect to principles of mechanical engineering, materials, including solids and fluids. Okay. So here I want to tell you regarding what is yet to be added to this already amazing tool. We are working to add more material categories, integrate charts and tables along with a format for answers involving mathematical expressions in a tabular manner. So it is able to do the mathematical calculations for you based on the built-in calculations which are available, mathematical expressions which are available, but it is not providing you in the tabular manner in order for you to understand step by step easily. So we are working to include charts and tables to this tool. Now, the current UI and UX which you see is a temporary one, and as if now we wanted you to focus more on the tool capabilities. That's why we have kept the UI and UX very simple. But later on, when the tool is finalized, you will get a lot of features which will be available within the UI UX screen. We'll also be adding guided material selection wizard to this tool. Also, we want the Matbot to be accessible to everyone, irrespective of their geography. For that, we need many more languages, and for the Matbot to be time saving and less cumbersome, we want to integrate voice capabilities so that you don't have to type the questions every time, right? We, because it is a conversation based tool, we want it to be a conversation based tool. Based on your voice, you ask the question, you get the answer. Now, let's talk about what is so unique about Matbot. I hope I have already answered this question based on the all the discussions we had and during the live demo also. But then also I would like to summarize it. So the answer to its uniqueness is turning your scattered, expertise dependent, or slow material selection process into an intelligent, traceable, and scalable AI driven service, which results in reduction of cost, quick decision making, and makes you more compliance ready than ever, right? Okay. So as we conclude, I would like to reiterate the key takeaways from today's session. First, we discussed about why we need to integrate artificial intelligence into conventional engineering methods, specifically for mechanical engineering and material selection. Challenges a user face while deciding on the material of construction due to the multiple factors that affect the material selection. At the same time, the presence of myriads of materials for each application which are available, and you have to choose any one out of so much available with you, right? Subsequently, we discussed on what is LLM, how it can be utilized to develop applications of interest using a strict training process, because ultimately the outcome of the LLM, trained LLM, will be based on the time you have spent on the training process, right? And how concrete is your training which you have provided to the LLM. Then we discussed the journey team witnessed while developing this tool, the challenges we faced while training the tool, collecting data and execution. Finally, we witnessed the live demo of the tool where we showcase the capability of the tool. Mind you, the tool is available, as I already mentioned. You can have a hands on it. Just reach out to us and we will guide you on the hands-on experience you can have with the tool. Now, with that, I come to the end of the today's session. I hope I was able to provide you insight into Madbot and which is a AI material selection assistant. Now, before we end, I would like to talk about the areas which we can collaborate to make better products, like to make the product design and development process much better. Right. Now, apart from the customized tools as Matpot, which I already discussed throughout the session, we also offer services from mechanical simulations, including structural, fatigue analysis, vibration analysis, drop, impact, and shock analysis. We can also help you to organize and work through or walk with you during the for design for X reviews for a particular product, for a particular application which you are working on, to understand the design from different parameters, manufacturability, maybe affordability, assembly, etc. Correct? We can also help you to create custom reports as well. So mind you, this is not the complete list of services which our organization provide, but this is with respect to the mechanical team which we provide. Okay, so where you can contact us if you want to have a hands-on experience on the tool Matbot, you feel free to reach out to me or Devesh. We would be happy to hear you from you with respect to the feedback of the session. Definitely, if you want to have a hands-on on Matbot, you can reach out to us, or any other topic, any other service which I have shared in the previous slide. Also, mind you, a recorded version of this webinar will be available on our website in a week's time from now. We will also send you an email on the email ID which you have used for registering to this webinar. Thank you so much. Have a nice day and keep learning every day. Thank you. Thank you so much.